Hi. You all seem to be expecting that I'm going to talk about machine learning, aren't you? Instead, why don't we discuss microwaves? Who here knows how a microwave oven works well enough to build a brand new one from scratch? Raise hands, any takers? No? No takers? Well, me neither. But who here has never used a microwave to heat food? Anybody? Any takers for that? Now, you just told me you have no idea how they work, and yet you use them. Why do you trust those microwaves? Well, you're not going to trust them by reading the wiring diagram, are you? You're going to trust them by checking what they do for you, checking whether they deliver what you needed them to deliver, tasting what comes out of them. And that is exactly the same thing that you're going to do with machine learning. Now, what they don't tell you about all those machine learning courses out there is that those courses are training you to build microwaves from scratch. They're not teaching you anything about cooking or innovating with recipes. And look, if your job is machine learning researcher, you are all about building general purpose tools, microwaves for other people to use, and then you'd better know how that thing works, because how are you going to build a better one than what already exists if you don't know that? But I bet what most of you actually want is to get cooking, to use machine learning to solve business problems. And where are the courses for that? Now, you don't need to know how to build a microwave from scratch. There's warehouses upon warehouses of these things. But if you're going to run an industrial-scale kitchen, there's a whole lot of other skills you need. You need to think about curating your ingredients at scale. You need to think about checking them. You need to think about taste tests. You need to think about not poisoning your customers. Now, I see a lot of businesses attempting to use machine learning and then failing horribly. And often the reason is that they don't realize that the algorithms research side and the applied side are two completely different disciplines. There's two machine learnings here. And instead, what they try to do, my friends, is they staff their kitchens entirely with people who have been building microwave parts their whole lives and have never cooked a thing. What could possibly go wrong, right? Now, if that doesn't go wrong, if it works out well for you, the reason is that you got lucky and you accidentally hired an engineer who just so happens to be a great chef. But usually you don't get lucky. We're not talking about this, but we should be. We should realize that what we are training the world to do is build all these appliances. And we're not teaching people how to use them. Now, we at Google are working to fix that. And that is why we have created the discipline of decision intelligence engineering. We've trained over 17,000 of our staff members in it already. Decision intelligence engineering covers the applied side. It is about taking applied data science and augmenting it with the best ideas from the managerial and behavioral sciences. It's about empowering people to improve their lives, their businesses, and the world with data, machine learning, and artificial intelligence. Hang on a second, though. What even is machine learning? Now, I'm a statistician and neuroscientist by training, and we statistician folk have a reputation for loving the driest, most boring-sounding names for things. We like it to do exactly what it says on the tin. So you know what we would have called machine learning if we'd been given the opportunity to name it? The labeling of stuff. That's what we would have called it. It is not a magical box of magic. Machine learning, it's just a thing labeler, essentially. But can you imagine actually staying in this track today if we'd named it thing labeling? The thing labeling track? Now, how does this thing labeling thing work? Oh, and artificial intelligence, the way that term is being used today, it's pretty much synonymous with machine learning. It's just a type of machine learning. So artificial intelligence also has rather little to do with sci-fi with a mind of its own. It's not something humanoid, it's also just about thing labeling. So let me take you behind the scenes, show you what's behind the magician's stand. How does this stuff work? You take some ingredients, and your goal is to separate them with a fence. So you use an algorithm to figure out where is a good, sensible place to put that fence, like there. Now, that fence, that boundary needn't be straight, and all the different algorithms will try to fit different kinds of boundary patterns in there. That's the difference between them, between these gobbledygook names. They're just separating your data. And what comes out when it's done is what you've wanted all along, a model. A model is just a fancy word for recipe, and you can now use this recipe to label your new incoming data. So this goes to red. See, it's easy. Now, why should you care? What is the point of this? This is my pet Huxley. You just took in some pretty complex data through your senses, and you get the label as if by magic. You just know that's a cat. And if I show you this one, you're not fooled, you still know it's a cat. Now, if we want a computer to do a task like this, to figure out whether an image has a cat in it or not, the traditional programming way involves the programmer thinking hard about the problem, channeling the universe somehow, getting inspired, and handcrafting a set of instructions that the computer must use to turn pixels into labels. But think about what those instructions would be. I mean, what did you do? What did your brains do with those pixels when you saw them? Can you articulate that? How did you take the pixels and turn them into that label? Your brain has had the benefit of eons of evolution, and now it just does it. And you don't even know how it does it. So how could you possibly write instructions if you can't even say what those instructions should be? Don't you wish that instead you could say to the computer, hey, here's a bunch of examples. Figure it out. That is what machine learning is all about. It is about explaining yourself to the computer with examples instead of instructions. And why is this exciting? Not because it's science fiction, but because it is a whole new programming paradigm. We can now express ourselves in a new way. And for some tasks, we can't solve them a different way because we cannot say what the instructions must be. Those instructions, those recipes, are ineffable. Machine learning, AI, they are about automating the ineffable. This is a fundamental leap in human progress. It unlocks a whole new class of tasks. You just couldn't do these before when you had to come up with the instructions. Now what you do instead is come up with examples, and the algorithm figures it out. This is the future. This is exciting. And the future is here. You want to use it. So what's your first step? How do you figure out where to get started? Here's a neat trick for you. I want you to imagine, when you begin, that there is no machine learning. It is all a hoax. There's just some island in the middle of the ocean somewhere, full of my friends who are sitting behind computer screens, and they are pretending to be an AI. And you send them some tasks, some inputs, and they just sneakily send you back a label or decision. If I let you use this island for free, what tasks would you give them to do? What drudgery would you cut out of your life? But there's one catch. You can't explain what they must do with instructions. You can only do it with examples. But I'm sure you can find really good things for them to do where they can learn from example, can't you? As you're coming up with those tasks, you are finding exactly the right applications for machine learning. This is thing labeling. Get creative with the labels that you want. Let me show you some examples of creative thing labeling that was actually done on Google Cloud Platform. Your label might be whether or not a baby food ingredient is safe or spoiled, to identify the bad ones and not let them into the finished product to keep our kids safe. Or maybe you are cleaning satellite maps, and your label is whether the pixel is snow or cloud. That helps you label it quickly. Maybe it's the control on a data center, the cooling system of that data center. We actually did this at Google. We got a 40% energy efficiency improvement when we let the AI set the controls. That's not just a lot of money saved. That's an incredible reduction in carbon footprint. Maybe your label is the speech caption for this talk, or it's the winning move in a game of Go against a world champion. Or it's whether to turn the steering wheel left or right. Your island can do this all for you, as long as you give them enough examples. But wait, just one moment. You don't know how drunk these people are. So don't just trust them with your important tasks. You need to make sure that you can check that your island can actually do the job properly. So only send them tasks where you could say whether a unit of work was done correctly, and set a metric, a bar, that that island has to pass for you to then accept it and start using it. Now, once you know what you want to cook, let's get into the kitchen. Imagine if your mission was to create, an edible sock that tastes of pizza. What's that process going to be like? How long is it going to take you? Which appliances are you going to have to use? And which ingredients will end up in there later on? You can't know that before you begin. But what you can do is intelligently iterate towards a solution. You have to go and you have to tinker and dabble. There's a lot you won't know in advance, and that's okay. Go play in the kitchen. Machine learning is just like that as well. It's safe and fairly quick to try out all the different appliances and different ingredient combinations. Actually, the dangerous mistake is allowing a bad recipe to get onto your menu. The tinkering and dabbling is fine. All that might waste some of your time. But getting a bad recipe onto the menu, that's a danger. And it's a danger that you can avoid easily. How? By tasting, by testing. And so, to think about testing, you already know everything that you need to know because you've been to school. Put yourselves in the shoes of a teacher or a professor. You need to make sure that your student, be it a human or a machine, can actually do the task properly and can do it on new situations, hasn't just memorized its way to a good score. So, what should you not do? Don't trust the student when it announces that it understands. Make sure you test it instead. Force it to earn your trust. So don't do this thing where you say, machine learning is magic, I just ran an algorithm, it's done, launch, off we go. Test it properly, check that it works. The other thing that you might be tempted to do, don't do this, is to say that you refuse to trust any model whose decision-making process you don't understand. If you believe that, please never hire a human. This machine learning algorithm that we have in our skulls is the most complicated one out there, and we have no idea how it works. If you insisted that you would only hire people whose, decision-making process for doing calculus you understand, you would have to go with a scalpel and dig around in the wet stuff. I'm glad you don't do that. Instead, what's the right thing to do? Test your student properly. Whether it's a human or a machine, test them. That means thinking carefully about inputs, checking the inputs, and making sure that the outputs that come out with those inputs are what you need. Testing is what keeps you safe here. It's not the wiring diagram of the microwave that is the best basis for trust. It is that you checked that it actually does the job you need it to do. The wiring diagram is pretty unhelpful to you, actually. If you had to choose, if you had only limited time, read the diagram or test the microwave, I'd say test the microwave every time. But do test. This keeps you safe. Now, professors, you also know that if your student might cheat and just simply memorize, then what you know is that you should never let any question that they might have studied from get onto the final exam. And that is why in machine learning, we make such a big deal about splitting data. Don't let any of those training examples wind up on the final exam. And statisticians will say, You have to only use your test data once. And you're like, whatever, pedantic statisticians. Stop nagging us. We'll use it more than once. Why not? Well, let me say that to you another way. If you give the same final exam to the same student 2 times, do not trust their performance on the second time around. Testing is what keeps you safe, and you have to do it carefully and properly. And luckily, you already know the principles of this. You just have to keep your wits and common sense about you. Force machine learning to earn your trust. Make sure that it works on new data, and new data that is like the data that you need it to succeed in later. You know that ingredients matter. A textbook is a great analogy for a data set. Just because you have a textbook doesn't mean that your student's going to learn what you want the student to learn. They're not magic. If you want your student to learn calculus, please open the textbook and make sure that it's not full of Japanese-English vocabulary pairs, because that won't help you get a calculus-enabled student. They'll find some patterns, sure, that connect Japanese and English, just won't be anything relevant to what you need. So if you're going near machine learning, I always suggest tattoo this sentence on yourself. The world represented by your training data is the only world you can expect to succeed in. Or another way of putting that is, whatever's in your textbook, that's what your student will learn. It's not magic. Just having a textbook isn't enough. Make sure that the textbook's appropriate. And again, the textbook is your data set. You are explaining yourself with examples. If they are bad examples, you have a problem. And the last piece that we haven't talked about directly is picking success criteria, objectives, incentive design, metric creation. How do you create metrics that can't be gamed? Your island is optimizing towards a score, and the way that score gets calculated is up to you. Now, I'm sure you've heard a story, a bedtime story as a kid, no matter what culture you're from. Every culture has this kind of story. Some person is given a magic item, a lamp with a genie in it, or something like that, and given an opportunity to make a wish. And they make a foolish wish, which is promptly delivered, the letter, not the spirit of that wish. And then everything goes wrong. And the moral of those stories is, be careful what you wish for. And I would say, wish responsibly. See, I see machine learning as the proliferation of magic lamps. And it's not the lamp or the genie that's dangerous. It is the wisher, if they're unskilled. If they don't know how to ask properly for what they actually need. Machine learning, the beautiful thing about it is that it will scale up an intelligent decision maker. But it will also scale up foolishness if that was what was cooked into how we test success. Machine learning, if it passes your testing, will deliver to you exactly what you asked for, not what you hoped you were asking for, not what you wanted, but precisely what you asked for. So please wish responsibly. This is something that decision intelligence does help you with, but a good start, my one request to you, is learn to be thoughtful. Think carefully about what you are requesting. That will save you a world of trouble. I believe that everyone should be communicating about machine learning because it is the future. And there's too much glitter and jargon and sci-fi in how these things are discussed today. So I made these 3 analogies for you so that you can use them to think clearly. Let the island guide you in finding appropriate machine learning applications. You don't have to think about it as a computer in order to find good examples of tasks to use it for. The kitchen should set your expectations for how you actually do the process, and that there is a lot of tinkering and dabbling, and that's okay. And finally, testing is what keeps you safe, so please test carefully. The hardest part is figuring out what you want to cook and how you would taste and check that what you've cooked has been delivered. Everything else is easier than you think. You don't need all those advanced courses in how the microwaves work. Instead, come play in kitchens. There's gleaming kitchens waiting for you. And every time I hear someone say, oh, they couldn't possibly get started with the tinkering and the dabbling before they take a course, or, goodness, a whole degree, Well, I can't help but think of them saying they can't use a microwave until they've built one. You don't need a PhD to do awesome things with machine learning. Dive in. Your machine learning adventure awaits. This is a really powerful new programming paradigm. You can now express yourself with examples. That is really cool. You can get so many tasks done that you couldn't do before. And the reason that machine learning is so hot right now, a lot of these algorithms have been around for over, well, 200 years for some of them. They're hot because the examples and the computing power to fit the algorithms exists now. The world is generating data like never before, and this is your opportunity to make your data useful. And because your first step is to think about the island and to think about how you would use those people if you could just offload tasks to them, you can all begin with the first step. You don't need data, you don't need computers, you just need pen and a paper and imagination. Start thinking about what you would use this for. And since that is the right first step, if anybody asks you, are you doing machine learning, are you doing artificial intelligence, you can, with a completely clean conscience, say, yes, I am. You are now all doing artificial intelligence. Congratulations. Welcome, machine learners. Your adventure awaits. Thank you.